Okay, I think it's right now. It's 5 o'clock in Japan. I think 10 o'clock in Italy. And good morning, good noon, good day, good evening, or even good night for everyone from all over the world. So our time is right. So let me start this webinar. Thank you very much. My name is Ji Dang, and I will introduce you about this event in the beginning. I will host and chair this webinar. So this is the EVACES-IA organized webinar. So what is EVACES? It's the International Associate for Experimental Vibration Analysis Field for Civil Engineering. And this International Associate serves as a platform for the peoples who are doing the experimental vibration analysis and related researches. And we organize few important events, including international conference, EVACES, which is even earlier than this associate. And we also actively foster the collaborations and partnership between the academic and industry. And thanks for the industry's help, we can run EVACES conference successfully. And we also support cementation activities for this related research area. So also we are starting to this kind of a webinar, so people don't need to wait 2 years to get together. This is the EVACES International Associate Board, which is including the chair, Professor Chunha in University of Porto, and Professor Maria was just a chair before, and also Pierre, he's organizing all this webinar very actively, and myself, which I'm from Saitama University, and I believe a lot of you know the Professor Filippo, University of Perugia, who will organize the next EVACES International Conference. And before I go to Professor Nishio, there's a few slides there. And we already have very nice organized EVACES-IA website. Before we only have the conference website. Right now, from the IA website, you can consider this international internet home of all associates, so that you can easily find the website of the conference, such as EVACES 2025, and also other events, webinars, past conference informations, and some news. So here is QR code if you didn't visit before. So please take picture of this slide and to access our homepage. Also, we also have our LinkedIn page. I think this is years very important for professional activities and careers. So please following us and send us a message if you have any request. The LinkedIn QR code also showing on the screen, so please easily take your phone to take the photo. And we will post our newest and dynamic messages on LinkedIn account also. Also, we have a very nice EVACES YouTube channel, including today's lecture. We will also upload to our YouTube channel, and the past webinar you can also check anytime from the our YouTube channel. Please also access and maybe reserve our YouTube channel on your web browser. And we have a very nice organized past international conference and EVACES. Each time we increasing more friends. I think a lot of you today joining with us also joined this international conference, which happens just in this July in Porto, Portugal, which Porto is a very beautiful city. You can see in this picture. We enjoy a lot. And thanks to the chair and co-chair, Professor Chunha and Elsa. And also with all the participants' effort, and we get 378 participants from 44 countries and 314 accepted papers. We collect these papers in this lecture notes in civil engineering, like our proceedings, volume 1 and volume 2, with very nice published by Springer. And also, we already announced our very exciting next EVACES 2027 in Perugia, Italy, which is a very historical and beautiful city. And welcome you to join us 2 years from now. And Professor Filippo will prepare, I believe, very nicely about this conference and hospitality. Here, please forgive me to pass quickly about our collaborations between academic and industries with our scientific members, with all of very famous and very active professors all over the world. And thanks our international industry committee members, they also cooperated and showed their most advanced technology in our EVACES conference. Also, you can check their works on their homepages. So finally, today, we welcomed Professor Nishio to give us the webinar of today's contents. This kind of webinar are very fresh opportunity to connect, learn, and expose the most advanced knowledge related to vibrations, and with distinguished experts like Professor Nishio. Professor Nishio, I would like to introduce a little bit. She is graduated from University of Tokyo, and then she went to the US for higher education. And then right now she is come back to Japan and doing a lot of advanced technology and development, and published many papers in famous important journals. And now she is working as in University of Tsukuba. And today she'll gives most advanced topic titled as video data utilization to structural damage evaluation during earthquake events, from experimental study to future resilience. So that's all from me. So I will hand the screen to Professor Nishio. So please enjoy the webinar.
Okay, thank you so much. I will share my slides, so please wait for a while.
During the Professor Nishio speak, and she will give us about 40 minutes or more presentation.
Maybe 40 minutes. Yeah.
40 minutes. And then we will have some time to do the question answer. So you can find a question answer button under your screen. So if you have any questions during the speak or after speak, please put a question on question Q&A. I will read it and introduce it to Professor Nishio and ask for her response. Thank you very much.
Okay, so first, thank you so much to all of EVACES board members for giving me this opportunity of this webinar this time. And thank you to Professor Ji Dan for chairing this time and this kind introduction. Okay, so my name is Mayuko Nishio, and this is the title today. I'd like to share many videos today and introduce our recent studies for leveraging video data to vibration analysis of civil structures. So first, I'd like to show one of famous videos shared on internet. This is the actual response of high-rise building to long period ground motions occurred in Great East Japan earthquake, March 11, 2011. The earthquake mainly attacked to Tohoku area here, but the long period ground motion caused typical long period vibration of those buildings in Tokyo. That is the near 400-kilometer distance from the epicenter of the earthquake here. So from engineering viewpoint, this video is very valuable because we could find now actual long-term, long period vibration occurred in actual structures. So actually nowadays, many videos are shared on internet, So when something happens, of course, when the disaster event occurs. So this is the ABC news site on March 12th, 2011. That is the next day of the earthquake. So it was reported that more than 9,000 earthquake-related videos and 7,000 tsunami-related videos have been uploaded to YouTube in the hour since the disaster began. So this video is also very famous video available on YouTube. That is the video in the Great East Japan earthquake. So actually, this is one of videos that I got inspiration of our study. Today, I'd like to introduce. So this person maybe wanted to record the situation of the city, Yokohama. So that is where is the second largest city near Tokyo. But seeing here, but I found that the phenomena of fitting or pounding at the ground surface connected to the building, that's provided me inspiration of this research activity, actually. So I had been interested in influence of damages on structural dynamics responses that those cause nonlinearity. So, there are three types of nonlinearity. They can be considered first, material nonlinearity, that is not only material yielding, but also open-closed behavior of crack damages. And the second is geometric nonlinearity, that is due to large deformation, and it causes nonlinear vibration combined with material nonlinearity. And there also be boundary condition nonlinearity. It is caused by increase of friction or existence of gap that causes contact or collisions. So we can find those nonlinearity in actual structural damages as shown here. There are the cracks and corrosion here. This is the damage on cable stay bridge. Here, the joint part is damaged, and that's caused the pounding and hitting events here. And there is the severe corroded bearing that's caused the increase of friction. So to analyze the nonlinearities of structural vibration, we have ever studied applicability of some feature extraction techniques. So this study is actually very long time ago, but we conducted a shake table test of a shear bending model, and that has seen this, a bumper, a column mechanism to introduce the nonlinearity on the structural vibration is installed. So that mechanism caused the kind of pounding events and pounding events during the random excitation. So here we found that the Holder exponent here, the whole that can extract the singularity in signals by analyzing holder continuity to wavelet transformed signal that could capture pounding events in good time resolutions as shown here. So I have got the idea of extracting singularity to detect those nonlinearity occurrence. So let's once come back to the shared video. Please find open-close behaviors of a crack on the wall here. Okay, so this is one of the nonlinearity I had been interested in. So we started a study of get the study of motivation to detect and hopefully evaluated those nonlinearity that will show, yes, here, those nonlinearity from this kind of video data. Okay, so this became a PhD study of Dr. Wang Shifan. He is now becoming my colleague, our team member here. And we adopted optical flow to extract both time and spatial domain feature. I think someone knows about the optical flow. The optical flow is the technique to calculate the velocity vectors of objects or feature points between two frames of video data. So there are a lot of interesting applications nowadays, such as object detection and tracking, and anomalous event detection, and deep fake video detection as well. So we thought that the anomaly of spatial vector field may indicate the singularity due to the local nonlinear structure responses occurred within the video frame. So the optical flow is based on an assumption called brightness constancy. Here, the intensity of a pixel is constant in small delta t, I mean the time, small time. By taking the Taylor expansion, we can obtain this function here. And here, the u and v, that is called pixel velocities, are estimated by adopting appropriate estimation methods. There are two basic methods. One is the global optimization approach. The other is the local approach. They both have advantage and disadvantage, of course, and I don't go through the details, but anyway, the points are accuracy and how we can get accuracy and how to capture large and non-smooth motions and computational cost. So this was the method we selected for our study called Fernebach method. This is also one of famous methods. Here it is assumed that the intensity function of local region can be approximately expressed by a binary quadratic polynomial as shown in this equation. So in this method, it is well known, recognized that dense vector fields is obtained by estimating from lower resolution in hierarchical resolution treatment as shown in this figure. And large and complicated trajectories of objects can be relatively well captured with lower computational costs. So first, let's see the result of application to shake table test video data. So this is one of open data acquired in e-defense facility opened by National Institute in Japan, that is National Research Institute for Earth Science and Disaster Resilience. Okay, let's see. Okay. So this is RC building, concrete building structure, and one of famous earthquake waveform, Takatori waveform, recorded in Kobe earthquake was input. So everyone can clearly find that the crack and collapse events occurred on outer world here. Then these are the results of optical flow. Here, when the crack occurs, just the time the crack occurs, the velocity vector with high magnitude emerges this part, and the direction do not become close to the other neighbor field as shown in this plot. So from this, we recognize that the velocity vector field would become a feature of detecting anomaly events. Then this is the framework of our proposed method. First, we take vector field estimation applying to optical flow to acquired video data and take feature extraction and feature enhancement procedures to capture the target event. Let's see a little more detail. So here is the test structure for our shake table test. We built 3-story share building model configured by aluminum members. And here, the point is here, we installed a special bearing mechanism for introducing transient boundary condition changes. So when the magnet here released, the boundary condition is changed from fixed stand to loosen rotation-free boundary condition. So we applied random excitation waveform to this testbed structure using the shake table. And the random signal is created by ourselves. That is the band-limited signal as shown here. And during the shake table test, we acquired video data as shown here. And let's see the video. Now the magnet is released and boundary condition is changed. And we also acquired acceleration data using the accelerometer as well. So then this is the result of velocity vector field estimation by Fehrenberg optical flow calculated by setting some parameters as shown here. In this video test, the bearing condition was changed in time of around 15.9 seconds, as shown here. So the frame at time of 15.97 seconds is during the magnet releasing events. That means this means the transient boundary condition change. So let's see this part around the bearing. So you can see that the vector field is disturbed, obviously, as shown here. And that is due to the event of hinge released during the random excitation as shown here. We want to capture we wanted to capture this disturbance of vector field. That is the point of our anomaly detection. So then we propose the feature extraction to capture the disturbance of vector field called extended node strength network. Here, high index value is given depending on the degree of disturbance defined by dot product of vectors. And we can obtain the result as shown here. Those colors indicate the value of the feature. But I think no one can see that, no one can recognize that the significant events around the bearing. Here, there are some patterns also around the joint of each floor. So next, we took feature enhancement procedure based on morphological operations. That is the name of the procedure that can delete layer texture. That is the obtained from the previous feature extracted feature field images. And by taking this procedure, we can only capture the anomaly parts here on the image. And now we can get the result of capturing anomaly events of boundary condition changes. Let's see. It's a little difficult to find. So, but when we extract the frame of time 50.9 seconds here, that is the time of the event bearing boundary condition changes, you can see that the anomaly is captured and indicated by this by taking this this method as shown in this figure. So how we can use this method? We consider about that. Let's come back to the video. This is another shared video taken by a drive recorder in northern Osaka earthquake occurred in 2018. That is the drive recorder video. So, seeing this, please find this big wall. So here you can see the crack is immersed and slightly visible the open and closed behavior of crack. So even though this driver didn't focus on this phenomena, just maybe this drive recorder want to capture the situation of the city when the earthquake occurred. But we can find that here that the singular, this is this a kind of structural damage event that can be captured by this kind of video as shown here. So we considered how we can apply the developed method to the video of a more realistic situation. One of issue was the influence of the uninterest part to the procedure, the computational cost of the procedure, especially the velocity field estimation. So we adopted deep learning technique to detect and remove region of uninterest, not the region of interest. region of ROU, region of interest. So we do not go through the detail today, but these are the structure of the deep learning model. And also, we adopted the weight transfer technique to measure lack of data issue and achieved over 80% accuracy for a detection of uninterested area. In this case, we removed the area of window and the doors. Those parts especially influence on the result of velocity field estimation and other next procedure of feature extraction and feature enhancements in our methods. So in this study, we used again the eDefense open video data. So this time we selected a shake test of two wooden house buildings with different basement and wall type as shown here. So let's see the video. Okay, I don't think no one find the event of crack occurrence. Please focus on here. Okay. Oh, I want to. Here. Here you can see the open close behavior of crack occurred on the beam of this wooden house. Okay. So maybe no one remarked here in this video, but we wanted to capture this by applying our method, our anomaly detection method. So here, this is the result of ROU detection and the velocity vector field estimation as shown here, and the feature extraction. And here is the final outputs of feature enhancements. So there is no highlighted part in the frame before the crack events, but we can find here the remarkable, crack was captured successfully, shown here. So there is one more shared video that can connect to our idea, our research idea. This is the video from a drive recorder shot in Note earthquake occurred in January 1st, 2024. This was a very severe disaster, and the area here is still in the process of restoration and reconstruction, So let's see. So the earthquake began. So you can find that many houses are collapsed or damaged severely. So now we are considering about how our research can contribute to this kind of the situation. Especially in this earthquake, the damage of wooden houses were severe. It is reported that around 30% of wooden houses in this area are collapsed or moderately damaged. The number is around 1,500, 1,500 houses shown here. And some reasons were pointed out, but one of them is that the history of seismic-induced motion has reduced the capacity of those houses before this earthquake event in 2024. So this is before this earthquake. Before this earthquake, we conducted another shake table test that may relate to the presented issue. Again, this was a shake table test of a 3-story building model, but this time we put wooden columns as showing these pictures. So the continuous wooden columns are connected to each of the floor plates and the basement by bolt joint. So the boundary condition is the fixed condition this time. So we acquired the video data and the acceleration data at the first floor here using the wireless sensor. And again, the random input accelerations was generated with frequency range of as shown here. And this time, we increased the amplitude level of input acceleration until the model was collapsed. So let's say some video. This is the response under low amplitude level. So here, we obtain the model properties as well. Okay. So increasing amplitude level, the vibration of the model gradually changed. You can see that the deformation modes of the columns, deformation profile of the columns are different from the that observed in the nominal condition, the previous one. So seeing the column condition, we found that some of the crack and delamination, as shown in those pictures, you can see there and here there is a slight cracks. Maybe that is the delamination. So this is the cumulative damage we recognized. So let's see the next one. I think you can hear 2 times sounds of the cracking. That is actually came from, let's see. Yeah, this one. That is actually came from this column. Okay. So by seeing the acceleration data, this event occurred in the time of 17.95 seconds as shown here, but we cannot recognize this is the singular event, the events with singularity or nonlinearity. So when we applied a wavelet transform to this signal, you can find here this indicates a kind of singularity in this waveform. So we wanted to capture this event from video data by applying our method. But before that, let's finally find the last one. The structure was finally collapsed. So we thought that this is the influence of the cumulative damage is also unnegligible to this kind of responses. So let's come back again. Again, we want to capture here. So by applying our method to the video data, we again derived velocity vector field by optical flow and took feature extraction and enhancement procedures as well. And these are the results. You can see that only the outputs in the frame of 17.95 seconds here. This is the time we can hear the sounds of cracking. That has a significant, this frame show the highlighted area clearly on the structure column. That is structure column, and that is detecting the nonlinearity on the structure vibration due to the damage occurrence here. So now I'd like to wrap up the talk today. We have now find that once a disaster occurred, a large amount of videos are shared on internet and they may become a valuable data. In Japan, there are efforts to preserve those videos by making archives handled by mass media, research institutes, or governments, including local governments. This is one of examples. You can find a website here, and but only in Japanese. But here, once we open this website, this is very good. We can find shared videos with information of location of the place this video should on the map as shown here. Of course, we can leverage those shared video data for remembering what happened in previous disasters. That means enhancing disaster prevention awareness. But also, additionally, those database might be useful for rapid assessment of civil infrastructure damage conditions. That means expanding engineering application for resilient structures. Okay, so yeah, I'd like to close the presentation. This is acknowledgement, especially thanks Dr. Wang Shifan. He is now assistant professor in University of Tsukuba and our teammate. And they are the lab mate. And yes, thank you so much.
Thank you, Professor Nishio. Thank you for the very extended talk. So now I would like to go to some Q&A. I didn't find any Q&A on my side, but maybe some of them you cannot use Q&A function. If you find difficult, you can also use chat to ask questions, because using this webinar style, you cannot directly talk and using your microphone. So I will speak for you. So if you have anything, I'm staring at the screen to check for the new message coming. So before there's any question coming, so I would like to ask Professor Nishio a few questions to warming up for the audience. So firstly, I think your topic is very, very interesting, and this kind of data mining using the internet video data, which is quite not been focused on before, because we are just focused on the recorded data, right? Using the very high cost sensor and to the house monitoring sensor, which is not easy to sustain, and for long time waiting until earthquake happens. So some sensors dead before they
Yeah,
are
right.
recording some earthquake data. So this is a quite important regime change of the using the data mining. So I find that in one of the experiment video you showed a car recorder, driving recorder of the earthquake of Noto Peninsula earthquake.
Yeah.
Which capture a lot of building damage, and also of the electronic pole leaning there. So is that you are implying that in the future we can also extract the maybe something like a vibration frequency of the building from the video, so that we can reversely to study about the character of the earthquake locally, because there's no earthquake sensor distributed very densely in that area. So we may need this kind of information. So
Well,
what is your comments on this kind?
what we are thinking about is the first evaluation of damage condition. This case, how to say, it is obvious unfortunately, many of the houses are collapsed, but some of the houses like this house, this house was not collapsed, completely collapsed, but remained the residual deformation. It looks like so. This kind of the damage degree can be evaluated from video data. That will become the good application of our method. So our more target, is like this. So these people focused on the situation of the city, right, when the earthquake occurred. But from engineering viewpoint, some crack occurred, and
developing.
there are images. So, but the
open and close, open and close.
Open and close. Yeah. So once when the earthquake event is finished, it is hard to recognize those crack condition.
I see.
Right. So
unless you use
point
e-defense to recreate it again.
Yeah, right. So, actually, we are the researcher, a structural engineering researcher, and we conducted experiment like shake table test. So, we know what happened during the experiment, but it is difficult for us to capture what happened during the event. That is the distance between the experimental study and the realistic, I think. But nowadays, lots of video data like this is shared, and the structural engineering field specialists can find what happened during earthquake event. So,
I see.
that is the point, I think.
Thank you very much. So during your answering, so there's quite a lot of questions pumped out. I think just people just typing. We just asking
Thank
the
you so
questions.
much.
So let me read the first one. First one is from Mr. or Miss Hosen. He said, "Hey, can we use a smartphone camera for feature extracting, or is a higher resolution or professional camera required? If so, are there any studies that explore the use of smartphone cameras for this purpose? Thank you."
I think the smartphone camera is should be used in this application. The first point is the performance of smartphone camera is very good nowadays. So it is possible to capture these kind of slight events. I think. The other is even though high resolution and high FPS are preferred, but the point of this anomaly detection method is just capture the disturbance of the vector field. So no need to capture the quantitatively accurate displacement. This is the point. So if we want to take the modal analysis using the video data, I think I know that I recognize that is also interesting and important topics, but it requires the high resolution, spatial resolution, and high FPS frame per seconds. But this method, we just capture the vector field. So it is applicable to various type of camera data, we think.
Thank you very much. So I think your answer also related to the second question from Tomaso. He asked, "Thank you for your presentation. What is the effect or other objects, such as people moving in front of the target region? So the quality of the results will be influenced, or is there any way to avoid the point tracking loss? Thank you."
Yeah, this is why we are approaching to use the deep learning technique. So we want to, first strategy is we want to we want to filter only the interested area of structure. So in current status, we only remove the window part and the door parts from the deep learning, but that's kind of technique. Maybe no. That's kind of technique here. Yeah, that can remove the person or other components existing on the city and only capture the target area, I mean the structure themselves. So by combining this kind of technique, we expect that this method can apply to actual realistic video data.
Thank you very much. So there's more question coming. So I will let you move to the last. So later, before you mentioned the sampling rate frequency. So this question is about that. From Shine Azite. He or she's question is there any trade-off between the video sampling frequency and the quality of the information we can extract from?
Yes, there is. If we use the video data with lower FPS, that means the longer time distance. So the accuracy and the kind of accuracy of the vector field estimation is influenced by this kind of parameters. So in the experiment, we of course cared about Nyquist frequency as a minimum requirement, but the high FPS data, video data, will capture more singular events successfully. So, but the point is,
So is there
Mhm.
so any contradiction about the when you have high FPS data and also with high quality, right? Also with high quality, you have very good
High
camera, but
resolution. Yeah.
the high resolution, both high resolution and high frequency. So is that the data size will be increased a lot. So
Yes,
that
right.
is that will
Yes,
be a
right.
problem?
It will be a problem. Yeah, that is the kind of trade-off. Okay, so the point is, again, we have no need to capture the accurate value of the vector, just the pattern of vector field. So we can try how to say try and we can try to use not high quality video data for
I
this
see.
application. Yeah.
Yes. So he also have a following up question. That is about is it possible to compute the vector field disturbance close to a real-time computation when the situation is needed.
Yeah,
Is there any possible
currently,
for now?
for now, we haven't tried about a real-time automatic procedure to this method, actually. I think it requires a little more advanced technique to realize the real-time analysis. So this time, we once take the video data and put the procedure of the computation procedure to capture the this anomaly events.
Maybe we need to use a very good GPU to do the calculation for
Yeah,
the
right.
high resolution.
Well, yes, right. Yes, right. Yes, right. For more fast evaluation.
Yes.
But
There's a
okay, sorry. Yeah.
There's a new question just came here from Giancarlo Costa. I think I met you in the conference. So his question is, thank you very much for the super interesting presentation. I was wondering about the data weight of the typical marrying campaign, even in consideration of the sampling rate, timelines, and definition. Would it be a problem for SHM applications,
Well,
which is short house monitoring way? Yeah.
so I think that means that the SHM under the normal operation. I think most of you know that the response level of the civil structure are very small under the normal operation. So it is a little hard. It requires a high performance camera this time to capture some kind of damages based on our methods. But the point is,
Yeah.
this is earthquake event, so the crack is opened and closed, and there are the swift behavior is occurred, visible. So in that case, lower cost camera data is applicable to capture and evaluate the damages.
Really, the question,
But
I think also
but it is interesting. We are also interested in the application to SHM under the normal operation. Yeah, thank you.
Yeah. I think also a few years ago, the Minister of Land and Infrastructure Transportation in Japan, some people also asking. So because also from the Nexco highway company in Japan, also we have a lot of civilian camera on the road. Is that possible to
Yes, right.
extract this kind of
Yeah, under the normal
request?
distribution, but because their camera is not the high performance, right?
Yeah.
Yeah, that's
And
for
also very
traffic.
poor insulation
Yeah,
also
yeah.
sometimes, yeah.
But if they can open the data during the earthquake event, this method is applicable, I think. So
Yeah.
yeah.
I think maybe they are not a very active YouTuber, so hope they can open data sometime. And also
Yes, right.
new questions coming, and two new questions coming. One from Mr. or Miss Bowman. I don't know if there's any effect the look angle of the camera to the analysis. If yes, have they been qualified yet already?
Not yet, actually. And this person is right. Yeah, very good points. So the camera angle and the environment of shooting environment is influenced, especially for instance, in this data, the camera is just in front of the wall, right? So we can find this slight crack, but this is the crack opened closed direction. The camera is the little outer side of the frame. It would become the difficult to capture in current
Yes.
method. Yeah.
But in experiment, we know where is going to bad things happen, so
Yeah.
we
Right.
targeted on
Right.
there. But in the real earthquake is like
Yeah.
the driver recorder, we don't know which is the angle. But this is the fun part of data mining, right?
Yeah, data mining and lots of big data, right? So there are
Yes.
many drive recorder and CCTV camera or something like that.
CCTV camera, yes. Also, from Mosen again, he is also asking, are you planning to integrate the kind of approach into the platform that can automatically receive and process videos? We know that this is from me. We know that we have the robot for before there was Twitter, now it's X. So we have robot.
Yeah.
It can automatically grab some information. So is that possible to link that to your technology to do some automatic extraction of the video?
I think it is very interesting if this for the SHM or maintenance in the of the structure under the normal operation. I mean that once we can bring the high performance camera on UAV, so we can capture, go to capture this kind
Mm.
of behavior, dynamic behavior positively, right? So
Yeah, I like
directly.
this idea.
Yeah,
Yeah, I like this idea.
yeah,
Yeah,
and yeah, that is good idea. And
yeah,
evaluate the detecting the damages and evaluate damage level and what kind of before behavior occurred in actual. It is very important, interesting. But the point is how remove the self-moving of the UAV. So
yeah,
this kind of computer vision technique is required to realize this idea. But I
yeah.
think this is very has a potential and interesting. Yeah, thank you. Thank you.
Also in the CCTV camera, and when they insert
Mhm.
for light pole themselves also have vibration. I think
Yeah, right,
for
right.
the drive recorder also, the car
Yes,
have
right,
the
right,
spring
right. Yes,
rocking.
right.
So how
Yes, right.
to use some anchor features inside the scene to get
Yes,
the
right.
0 point, I think will be
Yeah,
very
right.
important
Yeah,
technology
very
to
important.
solve
And
in the future.
actually, Dr. Wang is now working on this issue.
So expecting for his continual contribution to these topics.
Yes, of course.
Uh,
Yeah, and he is doing that.
yeah, I think we have quite a lot of questions coming today, but I think due to time, we need to end to this event. Am I right, Pierre?
Yes. Thank you.
Yes. Oh, okay. Thank you very much for the kind help. And Professor Nishio, thank you again for the very nice talk, and also thanks all the audience for the
Yeah.
very hot discussion today. Please focus on our YouTube channel for updating of this video and our incoming more webinar in the future. Thank you very much.
Yes, right. And thank you so much. Thank you very much, Mr. Dan, Professor Dan and Danji, and all audience and organizers. Thank you so much today.